Okay, so here, what's one of the zeros between what and what? Between, is it -1 and 0? Here, right? So here the y values switch signs, positive to negative, and the x values are -2 and -1. So we say between -2 and -1. And what was the other place? Right, here, between 0 and 1. I would always, the tendency in math is always go from the smallest to the biggest. Okay, so, okay, what about here? Between 0 and 1, right here, y values change, and then where else? 5 and 6, right. So between 0 and 1 and 5 and 6. Okay, good. So that's how we do that. Okay. Now, obviously, this is when, you're graphing by hand and you have to estimate where the zeros are. When we're graphing by calculator, there is no estimating because the calculator will tell you exactly. So go ahead and take out your calculators, please. And let's graph a function here. So we are graphing example number 3a. This is -0.5x squared. No, plus 6x minus 15. But what is important is for the negative, don't put the minus sign. Put the negative symbol. It does make a difference. Okay, now, we're going to graph this like this. Yeah. Menu, graph entry edit, function. Okay, now, here we go. Now we have, okay, this time we have to find the zeros, no longer the max or min. So, menu, everything is inside the menu. This is the difference between the new TI Inspires and the old versions. It's all menu-based like your computers are. Menu, analyze graph, right? Analyze graph. We have to find zeros. So you go to 0. Now, choose yourself which one you have to find first. Okay, I always do the left one first. So here, same thing. If that's the point, scroll to the left, click here. There we go. Yeah. Do menu, window zoom, number 5 for standard zoom. Yeah, so do menu, window zoom.
It's just going to be a line. I put an =0.
Okay, hang on, but let's do this. But that's a different issue. Menu, window zoom, and look at number 5 here. It's the standard zoom. So hit 5.
Yeah, it's still not there.
No, you don't put =0. That's why.
You just and then I'm going to go to tab and go to 5. And how do I get rid of this?
Oh yeah, yeah, you should.
Oh.
0.
Yeah, that's what happened to me too.
0.
Yeah. Then don't press the number 0. Oh, also. Also. You didn't put the X.
You press the word 0, the number 0.
Okay.
You in relation? Yeah.
So. Okay. 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 When you put this into the graph, only put the stuff here that I've circled in blue into the graph. Okay. Raise your hand if you have not graphed yet. Okay. So now, when you find the 0, it'll give you some number, comma 0. That's how you know you did it right, because the y value is 0 there. Okay. So here we're going to say, okay, x is equal to, now it says to find the roots, so you're just going to do x is equal to 3.55. To find the other one, you're going to do it again. Menu, analyze graph, 0. Now you go to the other point, to the left, to the right. You should get 8.45. You have to bring the cursor to this point. So you have to bring it to the left of this point. And here.
You put the lower bound on the left.
When you do the, okay, so now take a look up here for a minute. Raise your hand if you were not able to find these 2 points. Okay, now, can I have everybody's attention up here, please? Okay, I will come to you in a minute. Okay, now, another way that you can find all of these points is by tracing the graph, what we call traverse, like you can like traverse, you can just hop along the graph. So look up here for a minute. I want you to all press menu, and number 5 is trace. You can either scroll to these or just hit number 5. Then number 1 is graph trace. When you do that, you get the cursor and it'll always show up on the y-intercept. Now, to move this along the graph, you have to use the left and right arrows. So right now, everybody on your calculator, do menu, trace, graph trace, and get that cursor over there. Now, using the left and right, so I'm just going to hit the right button. Look, if you hit it once, it goes up, right? And up. And look at what's happening here at the coordinates as I press that. Now it's, okay, when x is 0.9, y is negative 10.05. So I can go through all of these points, 1.2 and so on. So if you keep doing this, but don't do it very quickly, we want to bring this up to y equals 0. Okay, but don't do it so quickly that you're going to miss it. Okay, negative 1.5. Okay, we're almost there. I do it again. You do it again. Look at what happened. It says here this is a 0. You see that? So when you do this, when you hop along the graph, it'll hit the important points. Now, now look up here, because I know somebody will ask me this on a test or a quiz. I have 3.55, and then here I've got this funny looking number, 1 e to the negative 12. This is scientific notation. It's 1.0 times 10 to the negative 12. What does that mean? 0.11 zeros and a 1. When you see something like this, e to the negative some number, you can just assume it's 0. Okay? Because the calculator does this algorithm where it's close to 0 but not 0. Okay. Some of yours might and some might not. It all depends on like the way your calculator did it. Okay. So let's move past again a little bit more. Now look at what's going to happen. Look, I'm up here, right? What's at that very peak? The maximum. So I go over maximum. You see that? It tells you maximum. So that's also another way to find the maximum. Okay, so now keep pressing until you hit the other 0. And if you're right on there, it says 0. Don't say you're at the 0 if you're like right closer. You have to make sure to read the word 0, and then you know that you're exactly on that point. Otherwise, you're close by, but not there. Okay? Okay. Isn't that all this cool stuff? Okay. So now, I want you to put in the other one. Okay. To put in the other one, here's what I want you to do. Bring everything to the right-hand side. I'm sorry, the left-hand side. So 13 minus 4x squared plus 3x. You don't have to put it in order. Just put it in like that. So how are you going to do that? You're going to go tab, press up, control delete, put in the new function and press enter. Okay, you should all have this, right? So this is good enough for you to find the zeros, because if you were to find the maximum, I would want you to zoom out. Okay, so I'm coming around to check. Okay, x equals negative 1.47 and 2.22. Okay, good. Let's do some word problems, because what's math without word problems? All right. So here's what we're going to do. Use the formula.
Wait, Ms. Malikin, did you write negative 1.47 and comma?
You can do comma, or you can do comma x equals. Okay, so we're going to use this formula. H is equal to B. Okay, This V subscript 0, the way we read it is V naught, N-O-T, V naught. It means initial V, T minus 16T squared, where, okay, H is the height of an object in feet, V naught is the object's initial velocity in feet per second, and T is time in seconds, okay? Fine. Marta throws a baseball with an initial upward velocity of 60 feet per second, okay? Ignoring her height, how long after she releases the ball will it hit the ground? What is the maximum height of the ball? Okay, so let's see what we've got here. We have that, a baseball is thrown, initial velocity of 60 feet per second. Okay? So what is this? Initial velocity of 60, what variable is it? V naught. So V naught is 60. Okay. Ignoring the height, how long after she releases the ball will it hit the ground? When it hits the ground, okay, so let's see what we have. We have this equation, and H is what? H stands for height. So when it hits the ground, what's the height? 0. Okay, so that's important. When it hits the ground, H is equal to 0. Okay, so let's do that. So first we're going to do that, and then we're going to do the other one. Yeah. Right. Okay, let's continue and you'll see. Okay. So this is when H is 0. Okay, so H of T is V naught T minus 16T squared. So that's what we're given. H of T is 60T minus 16T squared. And so we said H is 0, right? So H is 0, so 0 equals 60T minus 16T squared. So we have to graph this and find the 0, right? So let's graph and find zeros. Okay. So tab, get rid of this. Yes, we do x instead of t. So 60x minus 16x squared. Okay. All right. So I'm actually going to zoom out here. So menu, window, zoom out. All right, so it's way up there, right? So here's what else you can do. Go to Window Zoom, Window Settings. I'm going to show you guys something here. Go to Window Settings. Okay, so look at what you have here. Xmin and Xmax, it tells you what's the lowest value on the x-axis and what's the highest value on the x-axis. My graph is really in the middle there, right? So I'm going to make this -10. Tab 10. This tells you when you draw the x-axis, like how wide to make it. And then press tab. Y min, it shows you on your graph how low should the y value go. Since I really care about the zeros and not much below that, let's just make it -10. Tab. Y max is how high should it all go, right? And so we have, all these 60s and everything in our graph, right? So why don't we make this 70? It's a little bit of trial and error, and look at that. Look how nicely that looks, okay? So another way. There is so much to learn on these calculators, and this year, bit by bit, we're going to do a lot. Okay. So I made it 70. Okay, so I'm going to press escape here because I was in zoom mode. I'm pressing escape. Now, menu, look at where one of the zeros is, by the way. One of the zeros is at 0, okay? So this is very, very important right now. When I've graphed this, my horizontal axis, this is the t's, right? That's the independent, that's time. And then what's the vertical axis represent? Height. So time and height. So here, height is 0. Does that make sense that at t equals 0, height was 0? It does make sense because it started from here, right? Because we're ignoring the person's height. And then the next time that the height was 0 is when it fell back into the ground. That's the 0 that we want. And how much is that? 3.75. Whoops.
So T is 3.75.
Correct. And what are the units? Seconds. Now, the next question is, what was the maximum height of the ball? So how are we going to find that? Exactly, the vertex, right? If this is the height, okay, here the height was 0, then the height is at its maximum, then the height is 0 again. So you trace, you find the maximum, and how much is that one? Is 56.25 feet, I think, right? We're going to go to the hundreds place. Okay, so let's do one more. A volcanic eruption blasts a boulder upward with initial velocity of 240 feet per second. Again, we have V naught. How long will it take the boulder to hit the ground? If it lands at the same elevation from where it was ejected, what is the maximum height that the boulder reaches? So now V naught is 240. So what's h of t going to be? What's the formula, though?
H of T.
V naught t. So what am I going to write now?
H of T was 240.
Minus 16t squared. Okay? If I want this, you know, if I want where it hits the ground, right? Then I have to find the zeros of h of t. Okay? So this is another way of saying the same thing instead of you setting this equal to 0 like physically. Okay? So go ahead and graph. Huh? Yeah. So now, yeah. So let's go to here. Tab. Go up. 240 t squared x squared minus 16x. I'm sorry, yes. X minus 16x squared. I was like, why is it going up? Okay. No, because you have to zoom out a lot, okay? Because this takes a much longer time for it to come down. So let's zoom out a little bit. Menu, analyze graph. I'm sorry, not window zoom. Let's zoom out. I'm going to center it here. Okay. So you see how, okay, if I keep zooming out, it's going to make it so narrow that I can't even get in there and find the intercepts, right? So what I do instead, I escape. And so I go to menu, window zoom, window settings. I'm going to leave the x's the same, but for the y's, let's make it from like -10 again to, look, I'm already at 248 and there is nothing visible over there. So why don't I just go to 1,000, see what happens. Okay, so it looks like, okay, 1,000 is good enough, right? It's trial and error. You could put 500, still nothing. 700, still nothing. And then go, you know. Okay, so if I do menu, let's do trace this time. Look at where it is, right? It's up there this time. So if I move it left a little bit, okay, look, that's the maximum. 7.5 and 900. What does that mean? What's this 7.5?
Oh, like the distance they travel.
Not the distance. What does the horizontal axis represent? Right, the time it took to reach the maximum height was 7.5. And what was the maximum height? 900. Okay? So, maximum height, 900 feet. Okay, then let's trace. We gotta go this way. Yep.
Can you just double the time it took to get up there?
Yes, you can.
But what about does it gravity?
And here it's 15,0. Okay? So 15 seconds to reach the top. Okay. So 7.5 to reach the maximum. Uh-huh. 0 to reach, yeah. Okay, so max height is this, and then 15 seconds to reach the ground. Or, yeah. Okay, so the way these things work is, it's very, very symmetric. So this is the time axis from 0 to the end of the life span. The maximum is exactly in the middle, right? The axis of symmetry. So it takes half the time to go over there and half the time to go back. So you can use these to your advantage. All right? Okay, good.